Hi everyone, this is lesson 4 in module 1. Go ahead and write down your essential question. How can I tell if the data within a table is proportional? And what must be true if the table is proportional? Remember, tomorrow in class you're going to answer this on the page that has the summary. That's the bottom of 14. So we're going to stop right before that, and you're going to make sure that you put down your own summary in your own words tomorrow in class. Okay, if you need time, you can pause it. Otherwise, we're going to move on to this scenario. You have decided to run in a long distance race. There are two teams that you can join. Team A runs at a constant rate of 2.5 miles per hour. Go ahead and mark the text when you see that. It's a constant rate. That's telling you something. Team B runs 4 miles in the first hour, so that's pretty fast, and then 2 miles per hour after that. Create a table for each team showing the distances that would be run for times of 1, 2, 3, 4, 5, and 6 hours. All right, this is going to be pre-filled in for you. For Team A, let's go ahead and fill in 1 hour, 2, 3, 4, 5, and 6. So it says constant rate of 2.5. So 1 hour, 2.5 miles. 2 hours, that would be 5 miles because it's a constant rate. If you want to, you can write this in here. So this is times 2.5. Every hour is multiplied by 2.5, and that's constant all the way down. Hopefully you're catching on that that might not be the case for Team B. Okay, Team B, it says that they run 4 miles the first hour. That's why 1 hour, we've got 4 miles. Then 2 miles per hour after that. So now it goes up by 2. So up by 2, 2 more, 2 more. So each hour that it goes up by, the miles goes up by 2. A lot of people see this and they think, oh, it's going up by 2, so that's constant. Okay, the pattern goes up by 2s, but from the hours to the miles, this one would be times 4, but to get from 2 to 6, that's times 3. And then to get from 3 to 8 doesn't go in evenly. So you can already tell that that one is not going to work out the same as Team A. So let's go ahead and fill in some of these questions. For which team is distance proportional to time? We just talked about that, and you even have the proof right here. So hopefully you know that Team A is constant because there's a constant multiple of 2.5. Go ahead and write that down, pausing if you need to. Okay, now how do you know that the distance for the other team is not proportional? How do you know that it's not proportional? You can keep going if you need to prove. For 3 hours, it would be times 2.6 repeating, so already that's pretty messy. This one is times 2.5. That's interesting. All I'm doing is dividing the miles by the hours. But all you need to see is in one place it's not the same. Therefore, this is not proportional. It is not constant. Okay, Team B does not have a constant multiple. And you can even explain here that you have 1 times 4 to get 4. You would have 2 times 3 to get 6. And it just, it is not going to be the constant multiple. In fact, I want you to get in the habit of seeing multiplication like this. So 1 times 4, 2 times 3. That number in parentheses there is not constant. I'm going to jump to the 4 because 4 times 2.5 is 10. That actually came up in the first column if you were paying attention. But these are not constant multiples. Okay, so when would it be better to be on Team B than Team A? So I'm going to erase these now. Again, pause if you need to see the work, but I'm going to go ahead and erase it. When would it be better to be on Team B than on Team A? After 1 mile, is it better to be on Team B? Yeah, because you ran further. Okay, how about after 2 miles? Yep, I've still run further on Team B. What about 3? Still better. Well, look what happens at 4. So what I want to say is anything under 4 hours. So if you ran less than 4 hours, it would be better to be on Team B. Number 5, we're going to address that part that we just talked about with 4. Question number 4, though, asks us if the members on each team ran for 10 hours, how far would each member run on each team? So, to get team A, it's pretty easy to say I just multiply by 2.5. So just the same as we did up here. So pretend like the number 10 is down here, and you would multiply by 2.5, and you would get 25 miles. Now, team B is a little trickier, though. In fact, what I would do for team B, if you're not sure, just keep this pattern going. Pretend that it's been 7, 8, 9, 10 hours, and keep the pattern going. So I just kept going here, and now we'll keep going with the miles. So it's going up by 2. So we had 14 miles, so if we go up by 2, that's 16, 18, 20, 22. Again, if you're having a hard time seeing this, I'm just continuing the table for team B as if it were to continue on for each hour. So therefore, I can see that team B would have only run 22 miles in 10 hours. Will there always be a winning team? What do you think? If you look back, you can see where the tie is. There's a tie right there at 4 hours. So at 4 hours, they have each run exactly 10 miles. Okay, if the race was 12 miles long, which team would you choose to be on if you wish to win? So 12. I can see that in 5 hours for team A, I've run 12.5 miles. For team B, I've run exactly 12 miles. Hopefully that's telling you that at this pace, it's better to be on team B, because 12 miles is somewhere in here. I don't know quite where. We could figure it out if we had to, but the cool thing is I can tell it's got to be less than 5. It's got to take me less than 5 hours. And the way I can do that is I can take 12 miles and divide by 2.5, and that gets me 4.8 hours. So that's exactly how long it would take me to run the 12 miles. So go ahead and write that in, and then we're going to talk a little more about that. Okay, so the way that we got that was we did 12 divided by 2.5, because remember 2.5 was our constant. Now 4.8 is not in the chart because I could write all those in between hours in there, but really what I just want to see is 1, 2, 3, 4, 5, 6. However, I can still use that same math to figure out at 4.8 hours, I would run 12 miles. So just slightly less time for team B. For team A rather than team B, sorry. So for team A, it's a little less than 5 hours, and team B is exactly 5 hours. Okay, so how much sooner would you finish on that team compared to the other? So 4.8, that is not 4 hours and 8 minutes. It's not 4 hours and 80 minutes. A lot of times kids see 4.8 and they think that the 8 has to do with the minutes. 0.8 is a part of an hour. It's 8/10 of an hour. Okay? It's 8/10 of an hour. So you can write it actually 2 ways. I'm going to show you both ways so you can see how this works. You can write it as 8/10. The way you say it, 8/10, is how you write it, 8/10. If you're really good with your decimals and fractions, you actually know that 0.8, the reduced fraction, is 4/5. But I know that it's part of an hour, so I want to put this out of 60 minutes. Out of 60 minutes. Choose which one of these looks easier to you and go ahead and solve it. It's just like an equivalent fraction. Figure out how many minutes that would be. Go ahead. Okay, pause it though, because I'm about to tell you the answer. So pause it if you're still working it out. Okay, to get from 10 to 60, I times 6. So then I do 8 times 6, and that gives me 48 minutes. Should I get the same thing on the next one? Yes, because 8/10 and 4/5 are the same fraction. It's not 8/10 is bigger because it's got bigger numbers. It's the same fraction of a whole. So 8 out of 10 is the same as 4 out of 5. So to go from 5 to 60, I would times 12. And 4 times 12, you got it. It's 48 minutes. So that would be 12 minutes sooner because it's 4 hours and 48 minutes for Team A versus 5 hours and 0 minutes for Team B. Okay, so 12 minutes sooner. And there you go. That's problem number 7. All right, let's look at the exercises on the back. Bella types at a constant rate of 42 words per minute. Is the number of words she can type proportional to the number of minutes she types? So is the number of words she can type proportional to the number of minutes she types? So if she types for 1 minute, how many words is that? If you marked the text where you should have, you've got 42 words per minute. So 42 words in 1 minute. Go ahead and fill in the rest of the table and see if you got the numbers correct. Pause it, of course, if you need to, because I'm going to go ahead and fill them in now. Okay, 2 minutes would be 84 words. Let's put this X and Y here. We're going to get into that upcoming, so I want you to keep seeing that. 3 minutes, she could type 126 words. 6 minutes would be 252 words. Whoa, and then 60 minutes. So basically, if she types for a straight hour, she'd probably be really tired, but she could, at that rate, type 2,520 words. So each time I multiplied by that constant multiple, we're going to hear that word, so constant multiple, times 42, times 42. When you see that that math problem works for each part of the table, that's what makes it proportional, because each one of these numbers was multiplied by 42. All right, let's look at number 2. Let's see if this is going to be proportional. Mark recently visited a new state. During the first month, he visited 5 state parks. Okay, so right off the bat, they told us during the first month, he visited 5 state parks. So I can fill that in. Each month after, he visited 2 more parks. So complete the table to determine if the number of parks visited is proportional to the number of months. All right, so after 1 month, it's 5, and then it goes up by 2. So 5, and then after 2 months, it would be 2 more than that, 7. So for 3 months, 2 more than that, 9. Now, obviously, something is missing here because I didn't go up by 2 to get to 23. We're going to try to figure out how many months it would take to get to 23. In order to do that, I want you to kind of picture like a break in this graph, and we're going to continue our work up here. So let's keep going. It said after 3 months, it was 9 state parks. So let's say 4 months. That would be 11 state parks, okay, because every month is another 2. So then 5, 6, let's fill in a few so we can be efficient here. Okay, and then the parks is going up by 2, so 13, 15, 17, 19, at least we're getting there, right? Our goal is to get to 23. So let's continue. We'll even keep it going again. It's okay to do this because you want to be able to kind of see visually. So after 9 months, that'd be 21. And you can keep going up by 2s, 23, 25, 27. We didn't need to go that far. I just want you to see that the pattern would keep going. What I'm looking for is that 23 parks, and it looks like we're going to hit that right after 10 months. So go ahead and write that in. That's after 10 months. Don't just assume that it's 4. I know a lot of kids look at, oh, 1, 2, 3, just fill in 4. You have to read carefully and make sure that it makes sense. I wouldn't just go from 9 to 23. There's something that happens in there, and that's what we proved right here. Okay, the last example we have to do is finding the area of a square. And I want you to think about how you find the area of a square before we fill this in. This shows the relationship of the side length of the square and the area. So in order to do this, let's just draw a square, and this is going to be our visual. And we're going to call this side. And then since a square has all equal sides, we're going to also call that S for side. Okay, the first one is filled in. So we're determining if the length of the side of a square is proportional to its area. So if the side length is 1, what's 1 times 1? It's 1. Okay, so let's put that there so we can keep track of all the math problems that we've done. Okay, what if the side length is 2? What's 2 times 2? The reason we're doing 2 times 2 is because it's a square. Remember, the sides are the same. All right, 2 times 2 is 4. The next one, if the one side length is 3, then the other side length is 3. What's 3 times 3? 9. Good. Okay, you keep going. Try 4 times 4, 5 times 5, and then they want 8 times 8, and 12 times 12. Go ahead and fill all those in. You can show your work off to the side. I'm going to go ahead and fill in the chart. So pause it now if you're working on that. Okay, here's the answers. 9, 16, 25, 64, 144. Proportional means, did I multiply the same number? To get from 1 to 1, I multiplied by 1. Did I multiply by 1 here? No, I multiplied by 2. And here I multiplied by 3. So even though I'm doing the side length times itself, I'm not doing the same thing for every row. That's what you have to look at. This is not the same. This is definitely not proportional. This is not proportional because it's not the same constant multiple. Like up here, remember how for the minutes in words, it was always times 42, times 42, times 42, times 42, times 42. And then this one here, times 1, times 2, times 3. These are all different going across in the row. Okay, go ahead and wrap up, rewind if you need to go over anything again, and we'll do the lesson in independent practice in class tomorrow.